Okay, so we're solving exponential equations right here, and let's just continue on with what we've been saying right here. Which type of equation will this be? Will it be like we just solved when we had e to the x in our last example? Will it be like the first one where we had two matching bases? Well, let's find out right here. Before we start solving an exponential equation, even if it looks very complicated, the very first thing we have to do is isolate the exponential part. And so our first step right here will be to isolate 3 to the 2x plus 1. So isolate this part of the expression. And to do that right here, we have to add 5 to both sides. So we're going to get 3 raised to the 2x plus 1 equals 11 plus 5, that's 16. So this is definitely of this second type right here. All right, so what do we do? Well, again, we want to get an exact form. We want to get an exact form for our logarithm. And so the exact form that we're going to use the same trick that we just used before. That is, let's take the natural logarithm of both sides of the equation. So our trick, every single time here, our rule for solving exponential equations is going to go like this. We can say that if we have a equals b, then we can take the natural logarithm of both sides and say that the natural logarithm of a is equal to the natural logarithm of b every time it's tried, right? For all those numbers a and b that are in the equation. So our trick right here, if we apply it, means that we're going to take the natural logarithm, the logarithm of the base e, to the equation on the left, so 3 to the 2x plus 1, take the logarithm of that, and take the natural logarithm of the right-hand side, so the natural logarithm of the number 16. Okay, so now what do we do with that? Well, remember we had some properties that went along with this. We had a property that said if we take the natural logarithm of some base to some power, right, it was the same as taking that power and multiplying it by the natural logarithm of that base. So let's apply that right here. In this case, the quantity, our exponent of 2x plus 1, can come down as a multiplier in front of the natural logarithm of 3, and we set that equal to the natural logarithm of 16. So now solving is actually very direct. We can take both sides and divide it by the natural logarithm of 3, divide by natural logarithm of 3 on the left, divide by natural logarithm of 3 on the right, so I get the quantity 2x plus 1 is equal to the number natural log of 16 over the natural log of 3. And now we can just algebraically isolate x. So that means let's subtract 1 from both sides. So that 2x is equal to the natural logarithm of 16 over the natural logarithm of 3, all minus 1. And then multiply everything by 1/2. So I'm going to take 1/2 times everything on the left-hand side of my equation and multiply everything on the right-hand side of my equation by 1/2 as well. So I get x is equal to the natural logarithm of 16 over 2 times the natural logarithm of 3, all minus 1/2 times 1, so 1/2. Now, if we wanted to, we could combine this all together as a single fraction as well. We might find something like this: the natural logarithm of 16 minus the natural logarithm of 3, all divided by 2 times the natural logarithm of 3, but that is an equivalent solution. All right, so now that we know the trick, let's try another one right here. Right? Remember that our trick is to say that anytime we have an exponential equation in which we have something like this: a to the x equals b to the v, right? So this is actually this third type right here. What do we do with it? We're going to use that trick. If a is equal to b, then the natural logarithm of a will equal the natural logarithm of b. That is, we can just take the logarithm of both sides equally as a mathematical operation. So whatever you do on the left-hand side, you do on the right-hand side. So in our case, let's take the natural logarithm of the quantity 2 raised to the x plus 1 and set it equal to the natural logarithm of 5 raised to the power 2x. And from there, we're going to take advantage of our property that says that anytime we have a logarithm base b of some number raised to a power, we take that exponent down in front and treat it as a multiplier instead, so that we're taking the logarithm base b of a times the multiplier m. That should be an a right there. Okay, so taking advantage of this property, that means we have the quantity x plus 1 times the natural logarithm of 2. So I've gotten rid of my exponent being in the exponent position, the variable being in the exponent position, will equal to 2x times the natural logarithm of 5. So the natural logarithm of 5 and the natural logarithm of 2 become simple multipliers. And if we want to isolate x, that means that any x term that we see in our expression has to be gathered to one side of the equation. So the first thing I should probably do right here is distribute this natural log of 2 to both terms in the parentheses. So I get this: x times the natural logarithm of 2 plus 1 times the natural logarithm of 2 equals 2x times the natural logarithm of 5. So if I subtract x natural logarithm of 2 from both sides, I'll get the natural logarithm of 2 is equal to 2x times the natural logarithm of 5 minus x times the natural logarithm of 2. And I can use my distributive property now to get x out of that expression on the right-hand side there. So I would see something like this: the natural logarithm of 2 is equal to x times the quantity 2 natural log of 5, 2 times the natural logarithm of 5, minus 1 times the natural logarithm of 2. Now, be careful right here. Remember, you cannot combine these logarithms together unless their arguments are exactly alike. Now, we could use our subtraction rule or a few other things right here, but we want to just keep it spread out like this. It's probably the easiest. So to isolate x, we need to take one more step, and that is to divide both sides by this entire quantity, 2 natural logarithm of 5 minus the natural logarithm of 2. So if we solve this by division of this quantity on both sides, and I'll divide it on the left-hand side here as well, I'm going to get 2 natural logarithm of 5 minus the natural logarithm of 2. Look at what happens. I get x is equal to the natural logarithm of 2 divided by 2 times whatever the natural logarithm of 5 is minus the natural logarithm of 2. And again, we're going to leave it in this form because we're not really interested in the decimal version of all of this. So this is our exact value form. The next thing we would do, if we wanted to actually find its number, its value, is to plug these values into our calculator and figure out what it is. So we leave this answer in this form and we are done.